Here I'm using the analog write function in Arduino. I've got the serial print monitor open. Baud rate is 9600. You'll see it counting up to 255 and then back down to 0 again. 2 to the 8, 256, but remember that our very first bit 0, is actually counted as 1. So down over here I've got the LED running on the output. This is pulse width modulation. And you see here on my oscilloscope, if you watch carefully, you'll see the marked space changing over time. The period is the same. The on to off time ratio changes as we advance up to 255. So here it is now counting up to 255, and the brightness of the LED is increasing. It's quite hard to see the brightness of the LED changing with the camera. You might see it as it picks up at a low level. I've got an off period of about 50 milliseconds. There's a delay of 50 milliseconds as it goes through the next 255 steps. So if you want to enter this code, you'll get the same result as what I'm getting here. Down here, the code of our integer starting off at 0 for our first bit, going up to 255. You'll see that I is our integer value. If it's less than 255, the plus just means increment it up step by step, one at a time, to 255. When it gets to 255, it then resets itself back with a 50 millisecond delay and starts all over again. So you'll see here on the monitor just a little example of showing the analog write function in an Arduino, and being able to observe the pulse width modulation that is controlling the brightness of the LED. It's a 5-volt supply. The LED is running off a 5-volt supply on PWM. You'll see here my amplitude does not change. It's sitting on 5 volts, just over 2 and a bit divisions at 2 volts per division, and my period is set as well. But you'll see the ratio of the on-off time varying as we go through the time to reach 255. Thank you for watching, and hopefully this gives you some ideas when you're playing with your Arduino.